G'day guys, how you going? So just like the Backstreet Boys, we're back again, and what we're going to be doing is this Fieldwork RPA tutorial. Again, question videos. I'm going to start with a key question. This is the core of what you need to know. You need to be able to do this first part. I'll then go into extra detail for some of these extra questions, run you through my thinking and how I sort of step through those. Stay for the key question at the bare minimum, and then if you want to hang around and do some extra bit of learning, then you can hang in for the other questions as well. All right, guys, so let's start with this key question. So this is about the ecology or fieldwork RPA, all right? So some students wanted to find the number of thistle plants growing on a lawn. The students placed 10 quadrats at different positions on the lawn. Each quadrat was 1 by 1 meter, just like the ones we will have used at school. The students... No, our ones at school would be 50 by 50 usually. The students counted the number, I lied to you, this number of thistle plants in each quadrat. Which method should the students use to decide where to place the 10 quadrats? Should they place the quadrats out as evenly as possible, place the quadrats in place 5 quadrats in areas with thistle plants and 5 quadrats with areas with a few thistle plants, or place all the quadrats randomly? Now we know that it's all randomization, right? Okay, randomization is how we place these quadrats because it avoids bias, which is that place has got a lot of thistles. I don't really want to sample that because it's going to be uncomfortable and I'm going to get spiked, right? And so you don't put any quadrats there, which means you're actually going to think that there are less thistle plants in the whole field than if you actually sampled the areas with more thistle plants. So it's got to be random to avoid a human bias selecting and sort of influencing our scientific results. All right, it keeps them more accurate, as you would say. All right, so the diagram shows the lawn with the positions of the thistle plants and the students' 10 quadrats. We've got thistle plants, which are the little flower-looking things, and quadrats, which, funnily enough, are the squares. Complete the table to show. Now, this is where your underlining comes important, right? Complete the table to show how many thistle plants the students found in each of the first 4 quadrats, and the total number of thistle plants found in all 10. Okay, because this is a very easy question to overlook. There's a few flags. Make sure you read the stem right next to whatever you got there. Read it, and it will tell you what to do. The other thing is if you ever see marks next to something, don't just move past it, yeah? Because they want you to fill in these blanks. That's what they want, okay? And so that's what we need to do. All right, so in quadrat 1, how many thistle plants are there? So we look at quadrat 1 and we go, all right, there's 1, 2, 3, 4 thistle plants. And so we go down here, and this is it's really easy, right? It's a good question to have, but it's there anyway. Quadrat 2, 1, 2 thistle plants. 2 thistle plants. Quadrat 3 is 1, 2. And I am doing this live, guys, which is why it's slow. You have to keep up with my thinking. And in 4, there are 0 thistle plants, okay? So here we are. And so then we need the total number of thistle plants. All right, so we add them all up. Now, you can do this any way you want. All right, if you want to use a calculator, you can. All right, so we got 4 plus 2 plus 2 plus 1 plus 3 plus 2 plus 1, okay? So we got 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15. Let me double check that. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have a total of 15 plants. There you go, guys. For all of that, counting the flowers, 2 marks. All right, nice freebies. Okay, so calculate the mean number of thistle plants per 1 quadrat. All right, now what we do, we need to add up all the numbers together for all the quadrats, and then divide by the number of quadrats that there are. So in this case, we know the total is 15, right? So the mean, I'm just going to write, is equal to 15, which is my total, divided by the number of quadrats. And how many quadrats are there? Well, there's 10. Okay, and so 15 divided by 10. So the mean number, so you get your calculator and go 15 divided by 10 is equal to, okay, it's 1.5. If you're ever in doubt, always put it in a calculator. So the mean number is 1.5 thistles per quadrat, right? All right, done. And you got yourself your mark. 1.5 would get you the mark there. All right, so now we know that on average there is 1.5 thistle per quadrat. So the lawn measured 12 meters long and 10 meters wide. Use your answer to estimate the number of thistle plants on the lawn. All right, so let's get all mathematics on this, right? So we've got a lawn, which is a square there. we've got 12 on one, and we've got 10 on the other. So what we need to know is we need to know the area of this field. And so how do we work out the area of a square? Well, you multiply the length by the width. So in this case, the area of the field is going to equal 12 times 10, which is going to be 120 meters squared. Okay, so we've got 120 meters squared of lawn, and we've got, what do we have? We have a quadrat, which is 1 meter squared, wasn't it? Was it 1 by 1 meter? Yeah. So we have a quadrat, which is 1 meter squared. So how many 1 meter squared quadrats would fit in 120 meters squared? So it's 120 divided by 1. It's 120, right? So there are 120 quadrats would fit in this field. Okay, how many thistles were there per quadrat? Well, there was 1.5. So all we need to do, so the total is going to equal 1.5 thistles multiplied by the 120 quadrats that would fit. So you go 1.5 times 120 and you get 180. So there would be an estimated 180 thistles just there. Okay, and I hope me running through this working out sort of helps you understand what's going on. So how could the student make their estimate more accurate? What would be the best way to do it, honestly, is just when in doubt, if they say, how would we improve an investigation? The first thing to say is just add more quadrats. That's the best one to do, or add more samples, or add more whatever. So increase your sample size by adding more quadrats, and you could be specific. You could say, do 20 quadrats instead of 30, right? Okay, sorry, instead of 10, do 20 instead of 10. All of those are perfectly fine. Done. Perfect. Add more quadrats, and we are at 100%. So often these sort of fieldwork questions will come down to you have to do some of those calculations that we ran through in the actual RPA guide. All right, and that's the key question, guys. That's sort of the key question that I wanted to run you through. These are the extras. If you want to hang around and see some more thinking and see us repeat this, please do. If not, have a good one, guys. So for the heck of it. All right, so let's try this other question then. So ragwort is a plant that often grows as a weed in grassland. The image below shows a ragwort plant. There he is, looking gorgeous. So some students estimated the number of ragwort plants growing in a field on a farm, placed a quadrat at 10 random positions in the field, counted the number of ragwort plants in each quadrat. The quadrat is 1 by 1 meters, which is what it usually is, and the area of the field, a bit larger now, was 80,000 meters squared. The table below shows the results. Quadrat number of plants. Okay, so complete the following calculations to estimate the number of ragwort plants in the field using the information. So total number of ragwort plants in 10 quadrats. So what we need to do is we need to add these up. So 1 plus 0 is 1, plus 3 is now up to 4, plus 0, plus 0, plus 0, plus 5. So we're now up to 4 plus 5 is 9, 0 plus 0. So 9 plus 2 is going to take us to 11. So the total number there is going to be 11. So there are 11 ragwort plants across all of those quadrats. So the mean number of ragwort plants per meter squared. Okay, so we've got 10 quadrats, so it's going to be the mean is going to equal the total number of plants, which was 11, divided by the number of quadrats, which is 10. So 11 divided by 10, and again, whatever in doubt, put it in your calculator, is of course going to be 1.1. All right, so it's 1.1. So the mean number of ragwort plants per meter squared is 1.1. Therefore, the estimated number of ragwort plants in the field. Okay, so before we calculated our area of our field right here, they've actually given us the area. So we don't really need to do much more than this. All we need to do is we take our mean number per meter squared, which was 1.1, and we multiply it by the area of the field, which in this case is 80,000. 80,000, right? And so we go 1.1 times 80000, and we get 88,000. Oops, shouldn't have closed that. 88,000, right? And so this 88,000 would be your estimated number, and that's 2 from 2. Again, similar sort of stuff that you did before, but it's good to practice them. All right, how could the student get more accurate estimate? Well, we just went through this. Place the quadrat in 100 random positions, place the quadrat only in areas where they could see ragwort plants, or place the quadrats in positions at the edge of the field. Well, we remember randomness is what we want. We always want randomness to get more accurate data. So, of course, we're going to place it in the random positions. All right, the farmer who owned the field kept horses. If horses eat ragwort, the ragwort can poison them. The farmer considered two methods of controlling the ragwort in the field: spraying it with weed killer or pulling the ragwort out by hand. Method one is expensive, costs £420. The weed killer could not harm the grass but could kill other plants. The farmer could apply a weed killer and spray a towed by a tractor. Method 2 could be done by local volunteers. What are the advantages and disadvantages of using method 2 instead of method 1 for controlling? All right, so what are the advantages? Let's try and get 2, I think, of each for pulling the ragwort out by hand. Okay, so probably the big one is we're not using poison, so we don't harm other plants. Okay, other plants, all right. So we don't harm other plants by use of insecticide by using method 2. The other advantages of method 2 is that it's cheaper, okay, because your poison costs £420, which is money that it's not in your bank, right? Okay, so what are the disadvantages of method 2? So by pulling them by hand, it's probably going to be a lot more time consuming. All right, so it's going to be a lot more time consuming. And you're going to have help in terms of labour. And the other thing, it might not last as long. Because what will probably happen is that if you pull out things like ragworts or weeds, they usually have bulbs underground which would shoot back up. And so a disadvantage is probably that you actually removing the weeds won't last long and they'll come back quicker than if you poison them. And those would probably be 2 big disadvantages of looking at that. And it's just basically these questions are trying to get you to have a read and have a think there. And the disadvantage, another one, which is actually this one right here, the farmer could be towed by a tractor. It's more labour. It's more likely to actually harm yourself or hurt your body by actually having to pull these out. Whereas the weed killer can just be sprayed from a tractor while you're listening to your favourite tunes. All right, brilliant. So, lucky last extra question. This is actually looking at transects, this one, so it's a little bit different. Some students investigated the distribution of a dandelion plants in a grassy field. The grassy field was between 2 areas of woodlands, recording how many dandelions. So the picture shows them doing it. You can see the transect running along there, and you can see they're putting a quadrat along this transect. Shows sections across the area studied by figure 3, shows a bar chart of the students' results. Okay, so this is along the transect or along the tape in meters, it's 0, 2, 4, 6, 8, yada yada, and this is the number of dandelion plants that they collected, okay? That's a bit weird. All right, there's something going on in 16. Okay. How did the students use the Quadrat and 30-meter tape to measure to get the results? Okay, so what did they do? So they set out a transect between the 2 woodlands. Use the Quadrat and 30-meter. Okay, so they set out a transect between the 2 woodlands. And then what did they do? And then what they did was every 2 meters, they put down a quadrat. And counted the number of dandelions in the quadrat, right? In the quadrat. Okay, and then they recorded this on a table. And I would say those are the 3 parts. So they lay out a transect between those 2, along that field between the 2 woodlands, and then every 2 meters they will have put down a quadrat next to the transect tape, and they would have counted the number of dandelions in that quadrat. Okay. All right, it's just one reason why the student found no dandelion plants under the trees. Okay, so why were there a lot less dandelion plants here and here, there and there? What can you think? Well, what are the trees going to be doing? They're going to be blocking the sun, okay? Because the trees blocked the sunlight. Okay, and so if the dandelions got less sunlight, well, then they wouldn't be able to photosynthesize and grow. Okay, so just one reason why the students found no dandelion plants at 16 meters. Okay, so this one's a bit open to interpretation, right? So 16 meters is this odd one that I sort of flagged when I was reading the question, right? What could be happening in the middle of the field? Maybe there's a path there. So there could be a path there. Maybe, you know, that's somewhere where people walk a lot and therefore it's trodden. Maybe there's some poison or something in that location. But I think some of the best ones are something like a path, or where the humans walk a lot, okay, or where people walk, which is probably one of the things that's keeping those dandelions down there. And this is applying what you know from the RPA, just looking at a transect sort of quantity. Setting out a transect every 2 meters, putting down a quadrat and calculating how many dandelions are in that. And then trying to think on your feet and think of a few different ways to why there might be some anomalies in your data set. All right, guys, hope this helps. I'll catch you later.